Hey guys, what's going on? It's Danny. Today we're going to be talking about my first hackathon, which I had today. It was a lot of fun, and I learned a whole lot, and I hope you can learn something too. Whether you're someone who participates in hackathon, either at the collegiate level or even beyond that, or you're just someone like me who's maybe never participated in a hackathon, or maybe they're looking forward to their first time or their second time or whatnot. I hope that you can learn something from this video and learn from the mistakes I made and that my team made and the successes that we had. So I guess I haven't posted in a while, and I thought this would be a great video to update you guys on just kind of my journey, because I've been kind of making videos trying to teach you guys a lot about computer science, and I thought it might be worthwhile to hear about what I'm doing with my computer science journey, and this would also help because I'd love to hear feedback from you guys. So about the event. So I'm not going to name drop the name of the event or the kids on my team because that's not very relevant, but I guess for general context, my high school got invited to a hackathon at another local high school. It was four-person teams, and I was just with three other kids from my school. And I guess in terms of preparing for the event, that was where we reached our first challenge, which was when preparing for a hackathon, you need to know what you're going to be building in. Going into the hackathon, we looked at past projects, and we saw it was a game. A lot of them were just game-themed. So we had an idea that we kind of wanted to build a game, which we all had some level of experience with because in our high school computer science course that we've all taken, the final project is basically building some kind of game using Java. And so that's something that we all shared experience with and was something that we kind of wanted to do. But in terms of going back to the whole language thing, everyone on my team had extremely different skill sets, you know. Some of us know Java, Python, C++, JavaScript, and all these different libraries and languages and frameworks and just so many different things that we had a hard time trying to zero in on something that we all knew. And at the end of the day, we actually ended up going with Java because all of our school courses are our one school course is in Java, and we all have game dev experience in that, so we thought that would be the best to use. And in hindsight, I think it was a good decision to use, but yeah, it was fun. And so then I guess talking about the actual day of the event, it was from it was like 8 a.m. to like 6 p.m. It was like 10 hours. It was a lot, but it was a lot of fun. I really enjoyed it, but it was just a long day. So to talk about the actual project. So what we planned on doing was we planned on using Java because that was the only thing we knew how to use. And one of our teammates actually suggested using something called libjdx, which is kind of like a library that's very helpful for game development. And it was something new that only he had experience with, but we were hoping that going into the event, we'd all be able to like learn enough about it beforehand that we would be successful at the event, which I guess you'll hear about how that went. But yeah, so once we got there and we got the theme was connections. It was kind of vague, and when I first heard the word connections, I was thinking of the New York Times game, but then I was like, I don't think they want to see us build connections. I think they want to see something to do with connections. So the first thing we did was we kind of brainstormed, but we came up with an idea actually extremely quick. One of our teammates, actually, he's a senior, he's a little bit older, but he came up with an amazing idea that is what we ended up deciding on, and I think it should be available on my GitHub right now. We called it Crypto Connect, and to quickly explain the game. It's similar to those, if you can imagine those games where you have to connect the different color water pipes together and you're drawing little pathways and then they can't overlap and they all have to fill up the whole, it's so imagine that idea of like the connecting the pathways, but it's applied to our game. So our game, it's a grid, but it's like a CPU and it has little, we call them like little nodes, little things spiking off of the edge. I'm forgetting the name right now, but those were what are just on the outside of the CPU, and those are the input and output. And so the way our game works is you're given a contract, which is kind of like a story, and given this story, you have to create kind of like a circuit that will answer the story and create the proper output when given an input. So you'd be given an input at they're called pins. I'm remembering now. So there's pins on the edge of the chip that we used, and basically the way the game works is you have an input pin and an output pin, and these were supposed to be the original idea was that they were going to be was it randomly selected? No, they were just going to be you choose, and you can choose where the pins are, the input and output, and this allows you to kind of move it around and make it all work well. But the idea is that you're given an input as like a boolean. It's true or false, and you're given an output, and this output is based on this input given the story. So you'd have your input, and then you'd use logic gates to manipulate it. So that's your and, your or, and your not, and your XOR, and all the other logic gates that exist. But it was based off of those 3 simple gates that you can build everything else with. And that was how you were supposed to handle the internal logic, I guess, of the wiring. And so, for example, a story might be Jonathan wants to know if he needs to wear his jacket or not. Jonathan only wears his jacket when it's raining. If the input is 1, it's raining. If the input is 0, it's not raining. If Timothy should wear his jacket, output 1. And so for that specifically, you would do the input, and you would just bring it to the output. Because if the input's 1, the output should be 1. If the input's 0, output should be 0. For more complex cases, you might have to do not the thing. So that way, if it's 1, it outputs 0. If it's 0, it outputs 1. It goes on, but that was the basic game idea. That was the very core of our puzzle game, I guess. But we wanted to expand it and say that you're making money from each circuit you had going, each contract, and you could upgrade contracts, buy new things, everything at a cost. It was a whole system. And it was an amazing idea, and I was like, wow, this is a great game. It's a great idea, and something that I guess me and the other team members actually consider building as an actual project, not in Java, because we found at the end that we didn't like Java as much. But we liked our idea, and we thought it was a solid idea. It's something that we would pursue after as well. But so yeah, once we came up with this idea, what we did was we just kind of started building, and with all of us not having a lot of experience with it, I think that it was kind of a challenge at the start because we all had different ideas for how exactly we wanted things to go, and we weren't sure about what exactly we wanted each thing to be. And I think as a result of this, we had a lot of confusion. Well, not confusion. I'd say the confusion was negated because I think we communicated excellently when we had these misunderstandings and these things we needed to figure out. I think we communicated very effectively, and that was one thing we did well. But I think deciding the things beforehand, deciding the class implementations, what we want where, what we want everything to look like, the GUI, everything, I think we should have decided before. So our first mistake from this hackathon, I would say, would be, or second, I'd say the first mistake would be, I guess not, or no, I'll get into the first mistake I would say was we didn't fully map out exactly what we wanted. And I think if we spent 30 to 40 minutes, 10 to 30, like a decent amount of time planning out our project, we would have felt so much more confident and so much more efficient with our time. And because you're given like 8-10 hours to build during a hackathon like this, it can really be worth it to plan out all that time because it'll save so much stress and headache in the future. And so we started working on different parts. But another place we went wrong was some of our team members didn't actually have everything downloaded that we needed to use for this. And the Wi-Fi at the event was extremely poor, so we had to use a hotspot, which was also not very good. And as a result of this, one of our teammates actually was unable to contribute to our code because he wasn't able to download the library. And this was not a huge setback, but this was definitely a setback for us and something we weren't happy with because our teammate wasn't able to contribute. But sorry, he was able to contribute. He actually ended up designing all the pixel art, just designing all the art for everything. It was amazing, and we ended up making that work. And I'd say that adapting from the failures of not being able to code, I think we adapted very well, and that was a success of ours. And then, so I guess to move on from that, once we had everyone kind of coding, making the classes, I'd say another somewhat large mistake we had was that we shot too big. As we were building slowly and building up the project, we started to realize that a lot of these features we wanted to implement were just going to be so complex and very tricky. And we didn't think it was going to be... We ended up having to cut a lot of things at the end of the project, which was unfortunate, but something we just had to do. And so, so we were building our project as usual, hanging out, talking. It was an amazing event. It was lots of fun. I'd recommend, if you haven't been to a hackathon, go to a hackathon, find one, just get the experience, even if you don't do well. But so to continue the story, we were building our project. Everything was going all right. We were kind of making slow progress, but one thing that I noticed was that a lot of our team members, we had trouble figuring out what exactly each person should be doing at each point in time. And I think that was a result of our lack of planning. I think if we planned out fully every class, every little bit of everything, we would have been able to say, hey, let's look at the list. This is what you need to do. You can get on that. Awesome. And that was something that we struggled with, but in the future, I think planning is definitely planning is what the hackathon's about. You need to know what you're doing going in and everything about that. But yeah, so to get, yeah, so I guess I'm kind of stuck here because there is no really solid middle of the story. It was just, we were just coding for like 8 hours. We were coding. And as we reached the end, we started to realize our project might not get finished. And that was something that we did not want to have happen. So we started to cut out a lot of things and started to try to rush through things. And I think that was a good decision. I think that was a success of ours. We tried to adapt to the mistakes we made previously in the best way we could, which was simply by making sure that we knew what we were doing and making sure that we can cut out the things that we don't know how to do and finish what we have and have a finished project. And as time started to tick down, we basically the way our code worked is we built our full backend. It's built fully in Java and libgdx, so there is truly no backend. It's just like the backend logic, if that makes sense. We built fully the backend logic, everything from I guess checking the pins, analyzing the circuits. That was something big that one of our teammates did, and that was an extreme success of his, and something he's very proud of, and I'm very proud of him for that. It was a good contribution to the team, but he made a thing that will evaluate the circuit and see if the and the or and all the inputs and outputs work and whatnot. And that was something big we had. The algorithm was set up. We also set up the algorithm for all the different, like, I guess, questions, all the different questions we designed, and the contracts and jobs is what we called them. And we had all the backend set up, but what we found is that because none of us had intense experience with libgdx, was that our front end was lacking because not all of us felt entirely confident in coding the front end. And so as a result, it was kind of slower and not as efficient as it could have been. So to solve that problem, what we probably could have done and probably will do in the future is make sure that we're entirely familiar with these libraries that we're learning. Because by knowing exactly what you're doing, memorizing all these different methods and things, it makes everything so much easier. It's like, I can imagine one of the tools I know Java Swing. That's what we used in our CSA final project. I can imagine if we use Java Swing, there's so many of these methods and little bits that our whole team knows how to use. We know how to use these little things and all the little intricacies because have experience with it. So I think another key thing is having experience. Not only planning, but having experience actually using the tool, because when you use the tool, it's so much different than like studying the tool. Because you get access to all these different tips, different tricks, different things that can easily go wrong, and you can know how to solve these problems when you've had them before. And I think that was a mistake we made, but something that we plan to improve in the future. And so, I guess, yeah, so our friend was lacking, and so as we started to piece it together at the end, time really started to tick down, and our front end really was slow to come together, which is just unfortunate because we had an amazing back end, and we were confident that if our front end started working, we would have an amazing project that we thought would do very well in the competition. Regardless of that, we still actually did do well, which I'm starting to get to now. So we talked to some of the students that were running the event, and they said that it's unfortunate that you guys didn't finish your project, but you guys should still submit and see what we think, what the judges think. And we were originally doubtful at first. We were unsure about how our project would perform, and we thought, like, maybe we'll do good, maybe we'll do really good, maybe we'll do bad. And when it happened, it was quite a surprise. So our finished project it might be what's currently on my repo right now, but it's probably going to be updated at some point. We had the entire backend working flawlessly. We didn't actually have time to bug test it too well, but the backend worked, the logic worked. But the front end wasn't fully finished yet. We weren't fully able to place each component on the board, as I mentioned from before, like the little wires and the logic gates. Those weren't fully implemented to be placed on the board, and as a result of that, it was kind of difficult to actually play the game, which is something that you need to do to have a finished project. And so unfortunately, we didn't finish our project in the time, but because of our backend and I guess just our overall project, we didn't actually end up placing fourth in the event, which is something we were very happy with. And they said we won some kind of award money. We gave them our address, so we're going to wait and see and hear back and see what we get. But yeah, it was an amazingly fun event. It was something that I would definitely recommend to anyone who's interested in computer science at all. Because I think I don't have a crazy amount of experience with projects. I really enjoy LeetCode and all that data structure stuff because I'm also taking a course in that. But the projects it's very similar to actually like what computer science is. It's building projects, working with people, And learning as you go is also another part of it. I think part of that unpreparedness, part of that can be attributed to just learning. A lot of the times when you're coding, you're constantly learning. You're constantly looking up new things, finding out what error messages mean. And so when you participate in a hackathon like this, I think you really you learn so much. Me and my teammates, after the event finished, we were talking for like 30 minutes just about our plans and how we want to do another hackathon and how we were going to plan things out. And I think that doing these events and learning from them and in these competitive environments with time limits and everything, it creates a solid environment for learning, and just it's pressure. And I think a lot of the times, if you're able to flourish, if you're able to start making it work under pressure, I think that's an amazing skill to have. So yeah, I guess that kind of just about rounds up the event. To summarize, I built a project for the hackathon. We didn't plan as well as we thought we should have, as well as I think we should have, and that's a failure we had. The success I think we had was we definitely had a lot of our actual code was very solid and things that we worked on hard. But in the future, I think we should definitely work on our planning, our communication, and knowing exactly what we're going to do. Knowing all these things, I think, will be something that will help contribute to our success in maybe a future hackathon. We want to try to do one soon, so I think if we compete in that, I guess I'll make another video. Maybe I'll start this as a series where I talk about competitions after I attend them, and just talk about my experience and what I learned, what I did, what the experience I had, because there's a lot of people in the computer science world who unfortunately don't participate in a lot of these competitions because they think like, oh, I don't know how to build all that. Oh, that's too short time, or that's too stressful. But I think that even if you go and you're with random people and you have no idea what you're doing, you would learn just so much from these events, because failure is one of the best ways to learn. You can't learn if you're just constantly staying within your comfort zone. But yeah, I feel like I'm yapping a little bit. But yeah, this just about concludes my video. I hope you guys enjoyed, learned something. Comment down below if you want to see anything else. And comment down below if you want to see more videos about my hackathons. Thank you. And goodbye.